How do we identify minerals using their physical properties? We perform diagnostic tests on the mineral's physical properties and use a key to determine the name. Why is one a mineral and not the other? A mineral has a definition, a definite chemical composition, inorganic, solid, crystalline structure, and occurs naturally. Let's take a look at each of those. The D is a definite chemical composition. The chemical composition just means what chemicals it's made out of. Unfortunately, chemical composition is a difficult and expensive test. The I stands for inorganic. That means it's not living and it did not come from life. But there are exceptions. We're going to look at those a little later. The S means that a mineral is solid. The atoms have a fixed position. They're not a liquid or a gas. C stands for crystalline structure. That means not only is it a solid, but the atoms are arranged in a fixed pattern. And of course, O stands for occurs naturally. I like naturally occurring, but it doesn't fit the disco definition. Well, the definition tells us what a mineral is, but not how we can identify the mineral out of the roughly 4,000. So each mineral has a specific set of physical properties, and we're going to look at these physical properties and see how we can use them to identify one mineral and differentiate it from another. The property of luster is the way a mineral reflects light. We find that there are two main types of luster, metallic and non-metallic. Does the mineral look like a metal? It's metallic. Does it not look like a metal? It is non-metallic. But when we say it's non-metallic, we have a few other things that we can describe it as. For instance, we can look at minerals that are submetallic that may look dull, but the non-metallics, we can divide them up into vitreous, dull, greasy, pearly, resinous, silky, waxy, and adamantine. Another physical property is the hardness test based on the Mohs hardness scale. The hardness of a mineral is its resistance to being scratched and is rated on a scale from 1 to 10. A mineral hardness can be scratched by all other minerals, even your fingernail, and a mineral of hardness 3.5 plus can scratch a copper penny, and if the mineral's hardness is 5.5 or more, it will scratch glass. We can use the glass hardness to divide minerals in two basic groups, those harder than glass and those softer than glass. Remember, when we're doing some of these physical tests, we must be wearing safety glasses or safety goggles. A chip of glass could fly into your eye, doing some serious damage. So we will be wearing these in the lab. The streak of a mineral is the color of the powdered mineral found by rubbing it on a unglazed porcelain plate. Some minerals are harder than the streak plate, the unglazed porcelain plate, and must be powdered in a different manner. Oftentimes, minerals of the same color will leave a different streak. We can see the different streaks in this image here. Minerals also break. Fracture is how the mineral breaks along an irregular surface, where cleavage breaks along regular flat surfaces. It's based on their crystal composition and structure. Breaks can be described as grainy, hackly, jagged, or conchoidal. Let's take a look at grainy or uneven fracture. Here we see a sample of sodalite, and it has an uneven fracture. It's just rough. Hackly or jagged has a splintery look. Conchoidal is a special form of fracture that is sometimes called the broken glass fracture. If you've ever seen a piece of glass that's broken, it has these little curve-like lines or shell-like lines. And we can see a sample here of a glass-like rock called obsidian. Quartz also shows this same fracture, this conchoidal fracture. Another form of breakage is cleavage, and is noted by the number of directions that a mineral will split or break along relatively flat, smooth surfaces. We usually say 1, 2, or 3 directions. But there's also a quality. We can say it's eminent, that is, it splits easily or readily, almost on its own, to indistinct, where it's hard to even tell the fracture. We take a look at one sample of feldspar, and we see that it has 2 cleavage planes and 1 fracture surface. Color may seem the most obvious test, but rarely is diagnostic. Many minerals have the same color, and many minerals vary in color from this sample to sample. Quartz has a variety of colors. Other physical properties include, hey, but wait, there's more. um, Transparency, ductility, reaction to acids, magnetism, habitat. All of these things can be used to help us identify minerals. From that, we can use a decision tree, such as the one located at JMU, to decide which minerals